The next formulas that we're going to learn in integration are the reduction formulae. So there are some formulas which you need to keep in mind. So first is if In is integration of tan power nx dx. Is for example I10 is integration of tan power 10x dx. So if you are asked to integrate tan power 10x dx, the power is quite high. It will be difficult to integrate. So in such questions, when the power is very large, you can slowly reduce the power using the reduction formula. So reduction formula means at each step you reduce the power of the integrand. If I10 is integration of tan power 10x dx, then the formula says that I10 can be written as tan power 9x by 9 is tan power n minus 1x by n minus 1 minus of In minus 2. That is, if you start with integration of tan power 10x dx, in one step tan power 9x by 9 minus integration of tan power 8x dx. And for tan power 8x dx, again you can apply this formula. Integration of tan to the power 8x dx is tan power 7x by 7 minus integration of tan power 6x. So at each stage, the power of tan reduced by 2 units. And successively, if you apply this formula, you get the final integration. And In is equal to cot power nx dx implies In is equal to minus cot power n minus 1 into x by n minus 1 minus In minus 2. In is equal to secant power nx implies the formula is something like this. For cosecant power n, the formula is something like this. And for sine power n, formula is something like this. So you have these formulas. If you keep them in mind, the integration of higher powers of cosecant is higher powers of any trigonometric function is very straightforward. Otherwise, you can also derive this if you know that some reduction formulas exist. So just keep in mind that there are some reduction formulas if higher power of tan is given or higher power of cot is given. What I usually do is, first I'll derive this reduction formula and then apply this reduction formula. You need to understand how to derive these formulas. So I'll not derive all of them. So I'll derive some of these formulas so that you understand the basic concept. The next formulas are integration of x to the power n sin x dx is equal to minus x power n cos x plus n into integration of x power n minus 1 cos x dx. Integration of x power n cos x dx is x power n sin x minus n times integration of x power n minus 1 sin x. So these two formulas can be directly derived using integration by parts. And integration of x power n into e power ax. So here n can be any number in these three formulas. 1 by a x power n e power ax minus n by a integration of x power n minus 1 into e power x. So at each stage the power of x reduces by 1 unit. And log x power n is equal to x log x power n minus n times integration of log x power n minus 1. So at each stage the power n is reducing by 1 unit in all these formulas. So these four formulas can be obtained straightly from by parts. There is nothing much that you need to derive in this. For example, integration of log x power n. So if you want to integrate log x power n dx, so let us consider this as u, this as v. So what does by parts say? It is u integral v, that is log x power n into integration of 1 is x minus integral of du by dx. The differentiation of this is n times log x power n minus 1 into the differentiation of log x is 1 by x into integral of v. What is the integration of v? X. So this x and this x gets cancelled. So minus n comes out integration of log x power n minus 1 dx. So x into log x power n minus n times log x power n minus 1 dx. So these four formulas can be derived very easily using by parts. So let us do some sample derivations for trigonometric reduction formulas also, and then see how to use these formulas in questions. Now let us look at some sample derivations of the reduction formulas. So one of the important formula is integration of tan power nx dx is equal to tan power n minus 1x by n minus 1 minus integration of tan power n minus 2x. That is, in is equal to tan x whole power n minus 1 by n minus 1 minus in minus 2. So to derive this, let us see how we can proceed. So integration of tan power nx dx can be written as integration of tan square x into tan power n minus 2 into x dx, and that is equal to integration of tan square x can be written as secant square x minus 1, right? You know that secant square x minus tan square x is equal to 1. So tan square x can be written as secant square x minus 1 times tan power n minus 2x dx. Now if you separate this 2, that integration of secant square x times tan power n minus 2x dx minus integration of tan power n minus 2x dx. Now this is nothing but in minus 2, that is integration of tan power n minus 2x dx. You just need to prove that this is this term. So in this, if you put tan x is equal to t, then secant square x dx will become dt. So this secant square x dx goes to dt. So this integration becomes integration of t power n minus 2 dt, which is t power n minus 1 by n minus 1. That is tan x whole power n minus 1 by n minus 1. So this integration becomes tan power n minus 1x by n minus 1 minus in minus 2. So in is equal to this minus this. So this will be the reduction formula for tan power nx dx. So you can apply this in different situations. Integration of tan power 6x dx if you are asked to do this. So this will be tan power 5 by 5 minus integration of tan power 4x dx. Now tan power 4x dx can be written as tan cube by 3 minus tan square. So that is equal to tan power 5x by 5 minus tan cube x by 3, and minus of minus plus integration of tan square x dx. Now tan square x dx can be written as tan x by x minus integration of tan power 0x. That is integration of dx. So the final answer will be tan power 5 by 5 minus tan cube by 3 plus tan by 1 minus x plus c. So at each stage, the power of tan will get reduced by 2 units. So integration of tan power nx is tan power n minus 1 by n minus 1 minus integration of tan power n minus 2x dx. The next reduction formula regards integration of secant power nx dx. The formula is tan x into secant power n minus 2x by n minus 1 plus n minus 2 in minus 2 by n minus 1. So let us see how this can be derived. So you can write integration of secant power nx dx is equal to integration of secant square x times secant power n minus 2x dx. Now you have two functions. So I'll do by parts, assuming that second function is u and the first function is v. So what is the by parts formula? U integral v, that is secant power n minus 2x times integration of secant square x is tan x. U integral v minus integral of the differentiation of u is n minus 2 into secant power n minus 3x times the differentiation of secant x is secant x tan x, secant x tan x times integration of differentiation of u into integration of v, which is tan x dx. That is equal to secant power n minus 2x times tan x minus n minus 2 times integration of secant power n minus 3 into secant x times tan square x dx. That is minus of n minus 2 times integration of, this is secant power n minus 2x times tan square x can be written as secant square x minus 1 dx. That is equal to minus of n minus 2 times integration of, if you expand the bracket, secant power nx minus secant power n minus 2x dx. So minus of n minus 2 times integration of secant power nx dx is nothing but in minus in minus 2. So secant power n minus 2x tan x. So in is equal to this minus n minus 2 times in minus 2. So I will bring this in term onto this side. So this implies in times 1 plus n minus 2. That is n minus 1 is equal to secant power n minus 2x times tan x, minus of minus becomes plus n minus 2 times in minus 2. So if I bring this n minus 1 onto the denominator, you get the corresponding reduction formula. So integration of secant power nx dx is tan x secant n minus 2x by n minus 1 plus n minus 2 in minus 2 by n minus 1. So I hope you understand these formulas. So let us look at some examples where these can be used. So let us try to integrate cosecant power 5x dx. So let us use our standard reduction formula for cosecant power nx dx. So in is equal to minus of cot x into cosecant power n minus 2x by n minus 1 plus n minus 2 in minus 2 by n minus 1. So in this question you are asked to find I5, right? Cos cosecant power 5x. So I5, that is n is equal to 5. So just put n is equal to 5 in the given formula. So minus of cot x into cosecant power 5 minus 2 is 3x by n minus 1 is 4 plus n minus 2 is 3 by n minus 1 is 4 I3. So I5 is this plus 3 by 4 times I3. So I3 is nothing but integration of cosecant cube x. So now let us use the reduction formula for I3. That is equal to minus cot x into cosecant cube x by 4 plus 3 by 4 times. So for I3, I use reduction formula corresponding to n is equal to 3. So minus of cot x into cosecant power 3 minus 2 is 1. Cosecant x by 2 plus n minus 2 is 1 by 2 I1. So I3 becomes I1 in the next stage. So that is equal to minus cot x cosecant cube x by 4 minus 3 by 8 cot x cosecant x plus 3 by 8 times integration of cosecant x. I1 is direct integration of cosecant x. So what is the integration of cosecant x? Minus log of mod of cosecant x plus cot x plus c. So the final answer is minus cot x cosecant cube x by 4 minus 3/8 of cot x cosecant x minus 3/8 ln mod of cosecant x plus cot x plus c. So this will be the integration of cosecant power 5x dx. So I hope you understand how to apply these reduction formulas.